Today's lesson is on congruent figures, and pretty soon here we'll be dealing almost exclusively with triangles, but we'll start more generically talking about congruent figures. What are congruent figures? They're two figures that are exactly the same size and shape. So two geometric shapes are congruent, and I'm just going to use the congruent symbol there to speed things up. So we got a definition here. Congruent figures, or we're going to say congruent polygons. We're going to talk about polygons here. Congruent polygons have congruent corresponding parts. So in other words, the parts that match. Okay, when you name congruent polygons, you must list corresponding vertices in the same order. So what does that mean? Let's look at these two congruent quadrilaterals here. So they're telling us that quadrilateral ABCD is congruent to quadrilateral EFGH. So the order of those letters, which are the vertices, matters very much because it tells us the orientation that those things have to be in. Okay, so what we know, because ABCD is congruent to EFGH, we know that AB is congruent to EF. So if you look, you can see AB is in the same location as EF in our naming down here. Okay, BC is congruent to FG, so I'm just going to mark these parts as I go. AB is congruent to EF, BC is congruent to FG, and guys, because these are all each two sets are congruent to each other, we have to mark them differently, right? Like AB isn't congruent to BC, so we got to give a different marking to every set of congruent sides. So let's see, BC is congruent to FG, CD, put 3 marks on that one, is congruent to GH, and DA, I have to put 4 on that one. The A is congruent to HE. So even though these are set up so that they're mirror images of one another, we could turn that second one around so that it was in the same orientation, but we don't have to because of the way that these are named. We know which parts are congruent to each other. And also the corresponding angles are congruent. Angle A is congruent to angle E. It's over here. I'm not going to mark all these because it's going to get too messy in a minute. But you can see by the color scheme, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. All corresponding sides and angles have to be congruent in order for two polygons to be congruent. All right, let's see what we have here. Name the congruent parts of the triangles and write a congruent statement about the triangles. Okay, you know what I'm going to do is I'm going to write my congruent statement first because that's going to help me, I think. Let's see here. I'm just going to label the first one triangle ABC. All right, and now, because order matters, I got to figure out which angle in the second triangle is congruent to angle A. Well, angle A has the 3 marks on it, so that would have to be angle P. All right, which angle is congruent to angle B? Angle B has the 2 marks, so that would be Q. And angle C up here has the 1 mark, so that's got to be congruent to angle R. So there we go. Triangle ABC is congruent to triangle PQR. So we've already named the angles that are congruent. So let's name the sides that are congruent. AC. And see, this is going to make this easier because I've already named this. I can see that side AC is going to have to be congruent to side PR, right? So AC is congruent to PR. I mean, I can do this without even looking at my triangles. I know that AB, side AB here, is going to have to be congruent to PQ. So AB is congruent to PQ. And then BC, side BC, is going to be congruent to QR. So once we have a correct congruence statement, which is what that is, it's very easy for us to label the corresponding sides. Okay, let's see what we got here. In the diagram, quadrilateral DEFG is congruent to quadrilateral KLMN. Find the value of both X and Y. Okay, well let's see. So L here, I know that angle L is going to be congruent to angle E, right? How do I know that so quickly? Well, because L is the second letter here, E is the second letter here. All right, so therefore, because of the definition of congruence, I know that the measure of angle L equals the measure of angle E, and the measure of angle L is 5y plus 6, and that's going to be 111, correct? So 5y is going to be 115. 115. Hold on, not so fast. 111 minus 6 happens to be 105, I think. And so that means y is going to be 21. Okay, so there's y. Okay, now we got to find x. So we're looking at mn. I know that mn, and I'm going to skip the congruent step because I know that mn is congruent to fg because of the way these two are named. Okay, so they're congruent, therefore I know their measures are equal. So that equals MNFG 12, right? Let me put it that way. Okay, so now let me substitute in 5x plus 2 equals 12. 5x equals 10, so x equals 2. So there we go. There are x and y. Okay, finding congruent triangles. Are these triangles congruent? Well, how do we know if they're congruent? If all the corresponding sides and all the corresponding angles are congruent, then the triangles are congruent. So let's just look and see what we got here. Okay, we can see that angle A is congruent to angle E. We can see that angle B is congruent to angle D. So there's two sets of the angles, and then we've got two sets of corresponding sides. We got a 4 and a 4 and a 6 and a 6. Ooh, we got the other ones too. We got all three sides, so all we need is one more angle. But hey, we know these are congruent, don't we? How do we know that? By the vertical angles theorem. So yes, indeed, those triangles are congruent. I'm going to write a congruent statement. Triangle ABC is congruent to triangle ABC, that's going to be EDC. EDC, right? AB, let me double check myself. AB, so that's going to be EDC. Yep, that's right. Okay, let's see what we got here. A new theorem coming up. Recall the triangle angle sum theorem. The sum of the measures of the angles in a triangle is 180 degrees. The next corollary and theorem follow from this. The corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. So we know ABC is a right triangle. How? Because angle C is a right angle. Therefore, I know that the other two angles that are not the right angle are complementary, which means the sum of their measures is 90 degrees. All right, then we have another theorem. It says if two angles of one triangle are congruent, see like I have here, to two angles of another triangle, then the third angles are also congruent. So if angle B is congruent to angle E and angle A is congruent to angle D, then I know that those third angles have to be congruent, which are angle C and angle F. All right, that makes sense, doesn't it? Now, what do we have left? Oh, we've got some reflexive property of congruent triangles. Oh, you remember we had the reflexive property, symmetric property, transitive property of equality and congruence, and now we have these properties of triangles, not just segments, not just angles, but also of triangles. So every triangle is congruent to itself. Of course, that's the reflexive property. Symmetric property of triangle ABCD is congruent to triangle if triangle ABC is congruent to triangle DEF, then I can switch those and say triangle DEF is congruent to triangle ABC. And you may be thinking, why do I have to do that? Well, sometimes you'll have to do that in a proof to set up your next statement the way you need it to be. So we do need these properties. Okay, and finally the transitive property says if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then I know that triangle ABC has to be congruent to triangle JKL, right? Almost like the law of syllogism, transitive property. Okay, so this says we got some practice here. So yeah, just a couple of problems. So you know what I want you to do? I want you to pause here. I want you to work these practice problems and then come back and check your answers. Okay, here we are. So hopefully you realized that all three sets of the corresponding sides are congruent. DE is congruent to HG, and DF is congruent to HF, and EF is congruent to GF. And then I can see that this angle here is congruent to this one. And I know that these two are congruent by the vertical angles theorem, which means that by the third angles theorem, angle E has to be congruent to angle G, and therefore all corresponding parts are congruent. And write the congruent statement, even though it didn't say you had to, which is that triangle DEF is congruent to triangle HGF. Okay. Let's see what we got here. Find the value of x. Okay, well, let's see. I guess, I know that, okay, because I got two sets of corresponding angles, two angles in one triangle are congruent to two angles in another triangle. That doesn't necessarily tell me that these triangles are congruent. Keep that in mind. I don't really know that these triangles are congruent, do I? But what I do know is that angle K is congruent to angle C by the third angles theorem. So I just set up an equation there. 5x minus 2 equals 48. And oh, how did I know it's 48? Because I added 58 and 74, subtracted from 180, that was 132. Sorry about that. 132. And that's where the 48 came from. All right, and so when I solve this equation, I get x equals 10. Okay, this other one, just like it, again, I could not say that these two triangles are congruent, but what I can say is that this angle here is congruent to this one by the third angles theorem, and using the same steps that I used in the previous one, I get x 16. And finally, decide whether these two triangles are congruent and justify your reasoning. Well, they're right triangles. That's not to say all right triangles are congruent, because they aren't, but I can see that all three sets of corresponding sides are congruent, and I know that I've got two angles in this triangle congruent to two angles in this triangle. Therefore, angle F has to be congruent to angle Z by the third angles theorem. So yeah, those two triangles are congruent, and that's the congruent statement. Okay, I would suggest you write yourself a summary. You learned several new things there, and I'll see you next time.